Hi, this is Arthur at Proto 3000 giving you a quick tutorial today on how to use Vxinspect. Vxinspect is a module found within Vxelements that lets you compare your CAD data with your scanned mesh data for comparison reporting. The files for today's video will be found from the main menu in Vxelements under the Learn section and Tutorials for Vxinspect Tutorial 2. If you download these files, you can hit the blue arrow here and it'll take you to the program to follow along. So I hope you find this video informative. It should be about 40 minutes or so, and let's get started. So this is Vxinspect. Vxinspect is an inspection program that is a module of Vxelements, the native software and proprietary software that comes with all Creaform Ematex scanners. It'll run any of their digital devices. All of their devices will use the exact same software and workflow, which is really awesome. I've really enjoyed this latest release from Creaform, Vxelements 8. It's got a bunch of really cool features and tools that we're going to go through. Essentially, you've got a toolbar that tries to stay in order of operation for yourself, so you can go down the line. You have a navigation window, which has all of the different programmed items that will report out for you these specific areas of interest at their specific tolerances. We also have the actual inspection for part 1, but we can also go through each of them for part 2, part 3, part 4, and at any point we can go through and assess exactly what do these things report out and what can we ask them to report out, what can we change about what they're reporting out. Maybe we want their plus and minus. Maybe we go into the circle and ask it to report out its true position as a GD&T callout based on some of our datums, A and C. So really versatile, very quick and easy to use, minimalist interface. Quite enjoy it. Let's get started with Vxinspect. When you look at the viewport here, we have some selection tools which will allow you to flip between CAD and mesh, and a viewing cube here which lets you get your ortho views. So typically when you scan a part and you bring it in, it's at its own arbitrary world space, and a CAD model that you bring in will often be aligned to its original origin, which is more than likely where we want to start our initial alignment and inspection. So let's try and do an initial alignment for this just to start off the process. So we're going to start off with a surface best fit. Even if you're looking for a datum fit, surface best fit is something you usually have to do. So as you can see here showing up here, I'm going to minimize my face now. You get the name of this thing, so it's going to be the surface best fit. The mobile of the two is going to be our scan. Our fixed is going to be our CAD, and our pre-alignment is not going to be automatic. It's going to be manual. And I say this because automatic will sometimes work. You can hit OK and it'll just pop on, but more often than not, sometimes it doesn't. And there's various reasons about why, but for now, we can just hit the button and hit align, or I can show you the actual manual way of doing this. So if I hit pre-align, it's going to give me two windows. I can right click here to make sure I fit everything to screen. Sometimes these won't show up right away. So now that these are side by side and hopefully in the same orientation as each other, we need to do a manual alignment. So all that entails is doing a 1-for-1 picking point in the general areas between CAD and mesh. So 1 for 1, 2 for 2. I'm going to go center this bar, 3 for 3. And then for fun, I might do one more, maybe in the center, 4 for 4. So now that it's almost lined up and we've done 90% of the work, we can now hit align, and the computer will do the remaining 5%. This is often needed to help the computer finalize where exactly this mesh is going to go. So now that these are aligned, we can go and do a color map, which is the next logical step in terms of what we want to see. We're going to see the bowing and the different colors right away here as soon as we hit color map. So if I hit color map, you're going to see all the different features for color map pop up. We can give it a name. It's going to measure the mesh, which is called scan 1, against the whole CAD using our best fit alignment. All these are different things we can change out as we go. Which is a surface best fit, and these are the positive and negative values that are spread out in terms of where exactly this part sort of bends and flexes against the CAD over time. And it tells that story with the color map here. If we find that our window is too broad, we can always take these and drag them in and essentially tell a better story with the color map, which will update itself and show that those in colors a lot better. I'm going to hide my head here so I can hit OK. So if I do this now and hide our CAD file, you can see the color map right away. And so sometimes this is all you need in order to see where something is failing or how it doesn't line up in certain areas. And we can even take this a little bit further and use deviation annotations to just click on the part here. And wherever we click, it's going to give us that readout in terms of how far off the part these nominal areas are. So as you can see here, anything from red, orange to yellow is positive, and then anything below that in blue and purple is negative values. So this might be all you need. Sometimes we can do a few of these, then just hit a snapshot. So when I do a snapshot, that actually turns into a picture, which we can use in a report later on. And that also is a line item that will update itself based on which part you decide to bring in, especially if you have multiple parts of the same CAD file you need to report out on. That snapshot will update based on which parts you bring in. Very quickly, some of the other tools that you can use to do these kinds of checks will show up in this little section here. So if we do an add max and min annotations, it's going to find the absolute maximum and absolute minimum in terms of the deviation for us, which is sometimes useful. We can close all these annotations as well, and we can even copy them against each other between parts, which is nice. So now that we have this color, we can start to potentially work on now just the CAD model and maybe hide our part for now, because the CAD model is going to be the chassis for which we ascribe these different shapes to report out on. So for example, the first thing we want to do is we want to create some of the datums for this part based on a drawing. So the datums are the important features that everyone closely looks for and would almost align the part to in order to qualify its success. So the first thing I'm going to do is I'm going to make a plane, and this plane is going to sit on the top of the part here. This is a very important area, so I'm going to label this datum plane A, because that's going to be a datum alignment area that we're going to use. It's measuring against the mesh. It's going to measure scan 1. I'm picking on CAD for the nominal, and we're still using that alignment that we made earlier. All these different things here, too, are the different areas that this plane could report out on, and the different tolerances that you can program into each of those. Here's your variability. And then the surface profile callout, this is a GD&T callout. We can leave this if we need to, but because this is a datum, we could also delete it. But I'm just going to hit OK for now. So you can see a plane now is hovering over top of our CAD. So that plane is going to measure itself against the mesh every time we drop a new mesh in to report, and that plane is going to give us this particular reading, which we can find also too if we select the plane in the viewer. Let's make another plane. I'm going to need a plane here at the bottom, so that's another sort of plane. I'm not going to make this a datum though, because this is actually going to be used in construction. Construction is really cool though. So say I want to make a datum circle, right? But the circle is going to need a plane, and it's going to need some sort of construction method. And in order to construct a circle, oftentimes you need an intersection of two other things. So I've got a plane at the bottom. I'm now going to make a cone on the inside here of this drafted recession, right? So this cone is going to either report out on all these different things. I'm going to, for example, change this so that it reports its half angle out at 0.05. And negative 0.05. And, oops, sorry, that was the wrong one. So 0.05, negative 0.05, and okay. So that cone can now report out its half angle in the report. And if I ever want to change that, I can go through and pick these. I'm just going to actually move this over just a bit because I have my little controls for this little zoom thing. Oh, there it is. So I can actually see these now. That's what I didn't see before. So now that I have a plane and a cone in this area, if I want to go make a circle now, instead of just picking on CAD like we've normally been doing, this can now be a constructed entity. So this is actually going to be my datum B, this circle. and it's going to measure the mesh of CAD1 or scan1. But instead of CAD, we're going to actually do constructed. Where's constructed? So measurement method is constructed. So when we do a constructed measurement, we can do a plane cone intersection, which is really nice. Select your plane. We know that it's plane 2. Select your cone. You know it's cone 2, cone 1. And when you do that, you get a circle, and the circle can report out its x, y, and z coordinates as well as its diameter. The diameter is the only thing I'm really interested in though right now. So negative 0.05, and then, whoops, sorry, 0.5, and then negative 0.5. And we'll hit OK. So now we have, as you can see, we're starting to populate this list down here, hey, of all the different things that we're putting together. And so we got an A and a B, and we're almost ready for datum C. And datum C is simply going to be another plane that is a defining feature on this part. So I'm going to change this to datum C. We're going to measure the mesh of scan1, and we're going to pick on CAD for our datum. So that's going to be our datum there. I'm going to delete this callout at the bottom, which is a GD&T callout, because again, I'm just using these entities to align at this point, not to measure. So we hit OK. Now we've got our A, B, and C datums. Let's also talk briefly here about dimensioning, because you can also have dimensions in here as well that are just, dimensions and not primitive shapes. So there's a dimensions tab here that we can use for distance. I'm going to measure the distance, and this very much works like the construction method we just used. So I'm going to construct it based on our surface best fit, and it's going to be point to plane. So our points, and this is very interesting, this little window here, because this is like, this is everything you've made, and then these are different filters to help you find things quickly, especially when you get a lot of items in the tree. So, this is everything available. We can turn that off. But then I can also ascribe these things as well, these different filters. So I'm actually trying to look for this plane here, and then let's do the plane over plane 2. So it's measuring from this plane to this plane at the top, 1.6073 inches. And it has a 3D value that I can specify, and it's X, Y, and Z. What I want specifically is its Y. I don't want any 3D deviation at all. Thankfully, they're both the exact same measurement here, but it's better safe than sorry, especially if you get a weird part later on. We want to make sure that it's specified as just the Y that it's going to report out. And of course, we can change this later. But now we have that floating measurement here, which we can also even drag off the part so we can help see it better. And yeah, another dimension that we can do here real quick, say we wanted to use these similar concepts. Let's make a cone again, and I can call out this cone in the corner and say I wanted to measure from the center of this circle to the line of this cone, the axis of this cone. So same sort of idea, right? You would make a distance. It would be a constructed distance. We could call this something, center to cone variance, constructed. And instead of point to point, I'm going to do point and line. So point 1 is going to be the center of our circle, which is datum B. And we're going to select the line, which is also the line of our latest cone 2 axis. So again, we get this readout, 5.8072 inches. But that's a 3D measurement. I know for a fact that I'm probably only going to want the X readout, which is again the same thing, but we got to be safer than sorry here. We got to make sure this is X in the scribe. We can hit OK. So there's another dimension that we can use in our reporting. Here's an interesting problem. What if we want to check and measure the perpendicularity of this inside feature here to the plane, the datum plane on the top? Maybe they're very important and need to be related to each other in that absolute way. Well, we can go and check that using these very same tools. So I'm going to start off by making a cone. And I know it's a cone, unfortunately, because it's a drafted part, it's an injection molded part. So I'm going to ascribe this to both of those surfaces. 1, 2. Okay. And once we have it in place, there's a GD&T callout, of course, that we can ascribe and we can add. So I want to ask this member to report out in my report its perpendicularity. And its perpendicularity, based on a tolerance of 0.05, let's say, the primary is going to be datum A. So datum A is that plane. It's going to measure its perpendicularity to that. And if I hit OK, that is going to now be an item that we can report out to later. So now we can start to see all the different things as they start populating our list here. Okay, that, you know, if I go to plane 1, it's going to show me all the different things that these different members of this report could report out on, with all of their nominal, measured, and deviation tolerances ascribed. At any point, we can go back in and change these too. We can change the tolerances if we need to later on. We can ask this cone to stop reporting its half angle and instead report out its plus or minus value. Same with the values for these measurements. We can change their axis. We can make them 3D. This cone we just made has a readout of 0.007 inches for its perpendicularity callout, which is exactly what we've asked it to do earlier. So as you can see, we're slowly building up a report here and using snapshots and these different entities here, which we can rename and make more applicable to the callouts in a drawing, let's say. We can very quickly start to craft a report, which once written, all we have to do is drop in different meshes and hit export report. So let's talk about some of the other measurement methods that we can use on a part like this. For example, maybe we want to measure the edge here and the edge flange, and about whether it was cut in the right space or whether or not it's the right thickness. So in these reports, we can actually get a 2D curve to also report themselves out. I'm going to start by selecting one of the edges I want to use. Creaform is going to give me a constraining plane, and from there I'm going to select the rest of my edging that I want to report out in this report. So now these are selected. This is my range. I'm going to bring in these sliders here to something that tells a bit of a story in terms of deviation. I'm going to hit OK. And once that happens, this 2D curve can be seen in a 2D viewer. So if I hit the 2D view, you're going to see this curve that we made. I'm going to flip it so it's applicable. And you know, if you zoom in, you can see these little whiskers of deviation. But perhaps in the report, you're not going to be able to see that when we go to that. So down here, there's actually a whole tab dedicated to different ways of viewing all of the information here. So for this particular one, I want to take the whisker multiplier and just give it a big bump up so that I can see all of this. And this is what I would see in the report. And same thing as before, we can use these deviation annotations on the curve here to sort of tell a story about where and how badly some of these areas are. You know, and I can take these and move them around so they're not on any of the information for maybe perhaps another snapshot, which would be a great idea right about now. So if this is going to be one of my reporting features with a plus or minus deviation, I've got a pretty big max coming off of this readout. So I'm going to take a snapshot for them to look at later. But in here, of course, this display tab, right? It's essentially a tab from your window down to display. So glossiness, clip views, mesh displays, is it wireframe, is it triangles, CAD displays, how do they display? So definitely check this out. It's a good place to find for you know, customizing your view. So once I'm done with this particular curve and this snapshot, I can get out of 2D view and go back to the CAD model. And you'll notice that those annotations are going to stay with us in the viewer here. Might not be the best, most ideal thing. So again, we can use that close all annotations button here to bring that off of our viewer again. There is another way to capture complex surfaces and measuring complex surfaces. So for example, what if I wanted to measure the inside surface of this part here and to see that surface profile and how well that's adhering? We can certainly do that as well in this program. So let's go and make a surface. A surface is going to be just made up of a selection of different things that, again, will measure off the mesh, which is scan 1, and we're going to pick on CAD using this alignment. So if I go in and hold down Control, I can start selecting some of these different surfaces to report out on. And hold down Control, get that little fillet in there. And you'll notice too that that deviation map is showing up. If there's things in the way here to see, including my head, I can't get around that. Can I get to the other side? Oh, no. You can see that color map come in and show you just where it's using that information. So if that's good enough, let's hit OK. Can I move my head? I can move my head. Okay, I'm going to move my head all the way over here. Hello again. So let's try that again. So this surface, if I double click it again, let's go back into how it's reporting. I can move some of the windows again to change how it's the tolerances read out. And I can also measure differently by being able to select different areas of the mesh. Now, what I mean by that is that, say this surface has a profile and a color map, but you can see it's not fully measuring the full extent of the surface. It's cutting off the edging right around the corners. So maybe we want to refine that and bump that around a bit before we go to a report. So if with this selected, I can actually ask it to measure selected. And once we measure selected, we come across this double screen again, which is really cool. But now on the left-hand side, we have a bunch of tools to help us with our mesh selection in order to ascertain exactly which part of the mesh we're measuring. So for me, this all I need to use is one of the grow commands in this mesh toolbar, island toolbar. If I use the grow command, you'll see that it's going to grow that selection of measurement well into those areas that I wanted, which is perfect because we get more accurate result. And then if that's all I needed, I'm going to hit accept. So same thing, for example, if I scooch over here to this cone, cone 1, is it? No, it's cone 2. So cone 2, if I go and measure selected, we're going to get that double. And you can see how it's like not fully selecting everything in the area, right? So again, that can be something as simple as just growing that selection a bit more so we get more comprehensive coverage of that surface. To talk a little bit more about 2D curves. So we had done a 2D curve selection from a CAD model, but we can also do from a cross section. So cross sections are obviously very important. We can do an array of cross sections. We can do radial cross sections. We can do cross sections across a curve even. But for now, there's I want to make a plane so that it's an offset plane from this plane, but it's going through a point. It'll go through the center point of this circle and capture the center point of this whole profile here, which is what I'm after. So how do we do that? First, we got to make a plane in that area, and then we'll use that plane to create a cross section. So again, we're going to click the plane icon here. I'm going to change its construction method to constructed, and the method I'm going to use is a plane offset through point. So it's going to ask for those entities. I'm going to select plane, this one, 2D curve, and going to go to B center. Labam, there is my plane. And once I have that plane and I have that plane selected, I can do a cross section. Cross section. So measurement method is scan 1. Whole CAD is nominal, alignment best fit, linear single existing plane. So I'm going to select that plane we just made. And there it is. So let's drag that window in to get a better sense of pass or fail. And hit OK. And hit OK. And with cross section selected, again, I can go to 2D view, rotate that view, get that whisker multiplier up so I can see everything, and then add some deviation annotations just to get a sense of where this is going off for my reporting. And so if we wanted to use these same annotations for different parts, we certainly can, which is kind of cool. So all of these different points will report out in their position between parts and between scans, which is pretty awesome. So set yourself up for a snapshot again. Let's make sure all of this is offside the info that we need. And then take a snapshot. Snapshot 3 is in our report. That's fantastic. And we're ready to move on. We're getting pretty close now to finalizing our report. There's a few things left that we should try and do for ourselves here before we finish. One of the things is add a few more snapshots and maybe a title image for this report, because this is going to be a PDF report at the end of all of this anyway. So what we can do is we can start hiding all of our different entities which might otherwise be in the way. And let's just create some initial render views of the CAD model. So if I go Control-7, we will get the orthographic view. Not the best orientation for it, unfortunately. So fit to screen, and I'm just going to put this in a universal space. So I'm going to put this there. So this is what I would put in the front for, like, this is the CAD model that we're referencing. So I'm going to have that as a snapshot. And this snapshot I'm actually going to take and drag it all the way to the top of our report, because it's going to come in first if I do that. Let's do the same thing again for the part. So if I hide the CAD, show the part, do the thing, inspection, report, parts. Oh, please. Color map. I want to take a picture of the color map. That's all I'm trying to do here. There we go. There's probably a quicker way to do that. But same idea. I want to get that sort of informational report for the snapshot of the mesh. So I'll take a snapshot of that. And then maybe, because we're going to be potentially doing a datum alignment, right? Plane A is going to be on the top, and plane B, or circle B, and plane C are all going to be here too. So why does... So I've removed all the things now, got what I wanted. So deviations again, so we can add some deviations to the mesh just like before, but we can also add entity annotations, which is great because I want to be able to call out my datum plane, right? And this will show up in the screenshot as well. So that would be datum plane A, this would be datum plane C, and I might have to rotate around to get a better angle of circle B. So if I get this to the right space here, let's say it looks like this. Whoops, nope, don't do that. All right, now I got to go all the way around again. Just leave it. Just leave it there. Leave it there. Okay. So again, got to set up our little report picture. You only have to do this once, though. You do this once, and the rest of the mesh scans that you bring into here will follow suit just fine. It's just setting this up initially, so something like that might be a bit appropriate. And then I would take a snapshot of that as well. So we can talk a bit about datum alignments here too before reporting, because everything right here has been doing a surface best fit as its main means. But in alignments, if we now, because we have datums in place, we could do a datum alignment as well. So, you know, we could do a entity selection. Oh, sorry, datum reference frame alignment. So entities. Yes. No. So we're going to select datum A, select datum B, and select datum C as our reference points for a reference frame alignment. And what we get in the end, assign to all, it's going to remeasure everything to this new datum alignment. So if I go to my color map, you can see how it's a different color map now, right? All of my values now have changed. This entire report has changed because where it sits on the mesh is now different. It's not a best fit, it's a datum alignment. So alignments are very important in these reports, of course. So illustrating how you got to them, showing where those datums are on the mesh is going to be important. So, you know, snapshot 6, I'm going to save this as a snapshot actually, which I believe if I hop back into these, this is snapshot 7, snapshot 5, and it's changed. It's now the new color map, right? I can also ask it to fit to viewer window or show in front page, which is nice. So for my inspection, we got the scan and color map. Let's start throwing these into place here. So first snapshot is what? It's the CAD. That's fantastic. Second snapshot is the mesh. That's fantastic. So there's that. We've got our A, B, and C. So perhaps one of my datum pictures, datum A, B, C, which is snapshot 7, perhaps that should go and group itself with that initial grouping here. And then some of these other snapshots I know are cross sections, right? So we have this as a cross section, so that probably wants to live with the cross section area here. Snapshot 5 is color map again. We probably don't need a second one. Maybe I can just ask to delete that one. Snapshot 6 is another color map. Probably don't need that either. So that one can be deleted. And we have a snapshot 2 here for that 2D curve earlier as well, which is very, very, very different, as you can see now that we have done our datum alignment properly, or hopefully properly. Haha. So we've essentially compiled or have gone through the motions of making a report. So let's try and prepare this for final export here. So there's a report button up here, which we can just hit. And so customer name. So these are the things you put into the report. So this might be organization. I could, of course, spend the time, but of course, I'm not going to. All of this you would populate with yourself and your parts. The drawing number that you used, the active part. So you put all this, and then you hit export, and you're going to get an Excel file report. And they do this so that you can universally put it anywhere and edit it as you need up to. So report sample, I know you guys are in love with how I type. I know I am. For demos, my nomenclature is on point. So now that we have this exported report, we can hop over to Excel and just take a look at it. So my lovely form of writing is on top with all of those title and part informations which you saw, those title images that we sort of put in place, and then all these different things that we made, the reporting items. So the plane, the datum planes, the cones, the circles that were constructed by them. If anything's out of tolerance, you get these red markers here, which is exactly what the report's supposed to do. It's supposed to outline where things are falling short for you or a vendor or a supplier. And so these items you can edit and change out and drag around and add to whatever else you guys are using in this pipeline. And after all this is done, all you have to do to load your next part, once this is saved, because this is a whole program. You have to consider this like a program. You've written a program that sits and lives on top of a CAD model, and it'll tell you everything you need to know about the meshes you bring on top. Well, now that you've done this step, you don't have to do it again. All you have to do is add a part. So if we add a part, we're going to add another part to our list, part 2, and we're just going to go through the same motion of importing another mesh, which I unfortunately don't have right now. We import another mesh and then just hit measure all and export report, and that's it. And part 1, part 2, part 3, part 4, part 5 can all exist within the same CSF file. The entire inspection report can live in one file session, which is really nice.